creatine. You've probably heard of it, seen it advertised, maybe even got a tub of it sitting in your pantry right now. For years, it's been the go-to for athletes and gym goers. It's synonymous with building muscle and cranking up performance. But imagine if this common compound held a far bigger secret, a surprising connection not just to your gym gains, but potentially to how long and how vibrantly you live, especially if you're a woman. Welcome to the Deep Dive. Today, we're cracking open a brand new 2025 study from the European Journal of Clinical Investigation, fresh off the presses. Our mission for you, the listener, is to cut through the complexity of this cutting-edge research and extract the most important, often surprising insights. This deep dive focuses on creatine's nuanced role in your body's energy system and overall cellular function. Specifically, we're examining the relationships between different forms of creatine, what's in your blood, what's tucked away in your muscles, and the dynamic interplay between them and your ultimate risk of all-cause mortality. And here's where it truly gets fascinating. We're going to highlight some remarkable, almost stark differences observed between males and females. Think of this as your shortcut to truly understanding a fundamental aspect of your body's chemistry and overall health, aiming for those aha moments that will leave you well-informed and perhaps even reevaluating some health assumptions. Okay, let's unpack this foundational molecule. Creatine isn't just a supplement you pick up, it's an endogenous compound, meaning your body naturally makes it. It's absolutely essential for your energy metabolism and overall cellular function. You can think of it as your body's personal fast recharge battery system, crucial for those quick bursts of energy across many tissues.
Right. And what's truly fascinating here is the elegant way it works. In its phosphorylated form, which is essentially creatine with an added phosphate group, making it a supercharged energy donor, it becomes phosphocreatine. This acts as an immediate energy reservoir, particularly in tissues with incredibly high energy demands, like your skeletal muscles for power, your brain for rapid thought, and your heart for its tireless work. The creatine kinase system rapidly regenerates ATP, that's your body's universal cellular energy currency, from ADP. It's truly fundamental to life.
So it's crucial for everything from the most powerful muscle contraction to the subtle firing of neurons in your brain. It really is a powerhouse. But here's the twist that sort of reshapes our understanding. While creatine supplementation has been widely linked to benefits like enhanced exercise performance, muscle growth, even improved cognitive function, some prior studies have hinted that higher plasma creatine concentrations, that's the creatine circulating freely in your blood, might actually be linked to adverse health outcomes. We're talking unfavorable metabolic and cardiovascular markers like, say, elevated cholesterol or higher glucose. That's a bit of a paradox, isn't it?
It really is.
How do we make sense of that apparent contradiction?
That's precisely the core question this study aims to answer. If creatine can have these seemingly contrasting associations, depending on how and where we measure it, what's truly driving health outcomes? The researchers in this study, led by Cecilia Doorenbos, hypothesized that higher plasma creatine might indeed be linked to higher mortality risk. But, and this is the key, they made a critical distinction. They theorized that higher intramuscular creatine, the creatine inside your muscle cells where it actually does its work, would be robustly associated with lower mortality.
That's a crucial distinction, a really important one. But how do you even begin to measure creatine inside thousands of people's muscles without resorting to invasive muscle biopsies? That sounds incredibly impractical for a large-scale study.
You've absolutely hit on a significant challenge there. Directly measuring intramuscular creatine through muscle biopsies is indeed invasive and simply, well, unfeasible for a study of this size. So these researchers employed an elegant, non-invasive alternative. It's quite clever, actually. First, they estimated the total creatine pool size, essentially, how much creatine you have in your entire body by measuring 24-hour urinary creatinine excretion.
Okay, creatinine, that's the breakdown product, right?
Exactly. Think of it like this. A small, consistent percentage, about 1.7% of your body's total creatine, naturally breaks down into creatinine and leaves your body through urine every single day. So by accurately measuring that daily output, they could sort of backtrack to estimate your overall creatine reserves. Then to zero in on what's in your muscles, they measured muscle mass using bioelectrical impedance analysis, or BIA.
BIA, okay, that's the body composition measurement tool.
Right, because we know roughly 95% of your body's creatine is stored right there in your skeletal muscle. So you divide the total pool estimate by the muscle mass estimate, and voila, they had an elegant, non-invasive estimate for your intramuscular creatine concentration, IMC.
That is genuinely ingenious, a way to peek inside the muscle without a biopsy. It really changes the scope of what's measurable in these large population studies. So with this clever method, what kind of population were they looking at?
Good question. This study drew upon data from the prospective PREVEND cohort. It's a large, well-established population-based study based in Groningen in the Netherlands. It started with over 85,000 inhabitants, ultimately including 5,127 participants for this specific deep dive analysis. And critically, it featured a median follow-up of nearly 11 years, 10.9 years to be precise, which gives it incredibly strong statistical power to detect meaningful long-term associations.
And a significant detail jumps out here. They specifically analyzed everything separately for men and women. That feels like a very deliberate, important choice. What made them decide to stratify all their analyses by sex?
Yeah, that's a really critical detail, and it ties right into basic biology. The gene responsible for the creatine transporter, the protein that's essential for actually moving creatine into your cells, is located on the X chromosome.
Ah, okay.
And prior research already hinted at sex-based differences in creatine homeostasis, basically, how creatine is produced, transported, and stored, and how these differences might impact health associations. So conducting all analyses stratified by sex wasn't just, a good idea. It actually aligns with modern calls for more sex-specific reporting in medical research to truly understand these biological nuances. It's becoming standard practice, thankfully.
Okay, that makes perfect sense. So armed with this clever measurement method and a really robust study population, what did they find when they first looked at men versus women? Were there immediate differences in creatine levels right off the bat before even looking at mortality?
Absolutely. Yeah, from the outset, they observed significant sex differences. Looking at plasma creatine, females had notably higher median concentrations, 41 micromoles per liter compared to males, who were down at 28 micromoles per liter.
Huh, interesting. So higher in the blood for women.
Right. But what's even more interesting, perhaps, is that for the estimated intramuscular creatine, IMC, females also had higher mean concentrations, 30.0 millimoles per kilogram, compared to males at 27.4.
Wow, okay. So higher concentration inside the muscle too, even though men usually have more muscle mass overall.
Exactly. That's what makes it particularly noteworthy. Women had a higher concentration within that muscle tissue. Now, in contrast, males exhibited a higher median transcellular creatine gradient. That's the ratio of intramuscular to plasma concentration.
So how effectively it's getting pumped into the muscle cells?
Precisely. It indicates how much creatine is actively being pumped into the muscle cells from the blood. It was 955 for males, compared to 734 for females. This suggests men might have a greater capacity to accumulate creatine inside their cells against that concentration gradient, even with lower starting levels in the plasma.
Okay, so right away, it's crystal clear men and women are handling creatine quite differently. It really is like they're running slightly different energy management software, isn't it?
That's a good way to put it.
But let's get to the main event. What did these different creatine measures tell us about the ultimate test? The association with all-cause mortality over that decade-long follow-up.
Right, here's where it truly gets fascinating, and it offers a surprising resolution to that paradox we discussed earlier about plasma levels. During the 10.9 years of follow-up, 748 participants, that's about 14% of the group, died. Now, when they looked at plasma creatine, contrary to the initial hypothesis in some of those previous studies linking high plasma creatine to adverse metabolic markers, this study found no association.
No association at all.
None. No link between higher plasma creatine concentrations and all-cause mortality, either in the overall population or when looking specifically at females or specifically at males. The creatine just floating around your blood didn't seem to predict your lifespan in this cohort. However, the real headline finding was for estimated intramuscular creatine, IMC.
Ah, the muscle stores.
Yes. A higher estimated intramuscular creatine concentration was strongly associated with significantly lower all-cause mortality in the overall population. The hazard ratio was 0.62 per doubling. To put that in simpler terms, for every doubling of your estimated intramuscular creatine concentration, there was a 38% lower chance of mortality during the study period.
38% lower risk. That's substantial.
It really is, and this was statistically significant, even after they robustly adjusted for many potential confounding factors, cardiovascular risk factors like age, BMI, smoking, diabetes, kidney function, you name it.
That's a monumental shift in perspective. So it really is not the creatine easily measured in your blood, but the creatine packed away in your muscles that seems to be a strong indicator for longevity. That's a huge distinction that changes how we think about this compound.
Precisely. And if we dig deeper and connect this to the bigger picture, This strong association was primarily driven by the effect observed in females.
Primarily in women. How so?
In women, a higher IMC was very, very strongly associated with a significantly lower risk of mortality. The hazard ratio there was 0.43 per doubling.
0.43. That's a 57% lower risk of mortality for every doubling of IMC in women.
A remarkable 57% lower risk, yes. It's a very strong signal. Now, for men, there was a weaker trend initially with a hazard ratio of 0.73 per doubling, suggesting maybe a 27% lower risk.
Okay, still something, but weaker.
Right, but here's the key difference. This association in men completely lost statistical significance after they applied the full adjustment for all those potential confounders. It basically vanished statistically.
Wow. So a huge, highly significant 57% lower risk for women. And for men, the statistical link essentially disappeared after accounting for other factors like age, BMI, etc. That's not just a distinction. That's a powerful, almost stark divergence between the sexes. That has to be one of the study's most important takeaways, surely.
Indeed, it really is. The difference in the strength and the statistical significance of this association between the sexes is quite remarkable. It really highlights that biological sex can play a fundamental role in how even a basic compound like creatine impacts long-term health outcomes.
Yeah.
And just to round it out, that creatine gradient, the intramuscular to plasma ratio, it initially showed maybe a borderline association with lower mortality, but like the finding in men for IMC, it too lost statistical significance after the full adjustment. So another really important insight here is the clear disconnect they observed. Plasma creatine levels do not accurately reflect what's going on inside the muscles.
They don't mirror each other well at all.
Not really. Although there was a statistical correlation, as you might expect, only a tiny proportion of the inter-individual variability in plasma creatine was actually explained by intramuscular creatine. We're talking less than 1% in females and just 3% in males.
So what does this all mean for us practically? It means you literally can't look at a standard blood test for creatine, which isn't commonly done anyway, but still, and know what's truly going on inside your muscles. They're distinct indicators telling different, apparently independent stories about your body's creatine status and its potential impact on health and longevity.
Exactly right. Plasma creatine is influenced by a whole myriad of factors. What you eat, how much your body synthesizes itself, how much your kidneys might reabsorb, and how much your cells might release under various conditions. It's a really complex interplay of mechanisms, and based on this study, it's clearly not a reliable proxy for the creatine stored and actively working within your muscle cells, which seems to be the metric that matters more for mortality risk.
Okay, this finding about intramuscular creatine being so strongly linked to lower mortality, particularly in women, is genuinely profound. It really makes you rethink creatine's role beyond just athletic performance. So what does having a higher concentration of creatine in your muscles actually mean for your overall health and longevity? Why might it be so protective?
That's the million-dollar question, isn't it?
Yeah.
And while this study, being observational, can't definitively prove cause and effect, the researchers offer some compelling hypotheses based on creatine's known functions. They suggest that higher intramuscular creatine concentrations could reflect, maybe, better overall muscle quality or function, and perhaps just a higher, more optimal creatine status throughout your body's cells.
So it's not just about having bigger muscles, but maybe healthier, better functioning muscles.
Precisely. We know muscle mass itself is protective. That's well established. But this seems to be about the quality and the metabolic readiness of that muscle. Higher IMC could contribute to increased resilience against things like frailty as we age. Ensuring your muscle cells have that immediate energy boost available to recover faster, maintain strength, potentially helping prevent falls, which are a huge issue.
Like having a deeper, more readily available fuel tank in every muscle cell.
That's a great way to think about it, making them more robust against the general wear and tear of aging or physiological stress. And beyond muscle, we know creatine plays roles elsewhere. It's been linked in other research to potentially improve neurocognitive function, maybe some neuroprotective properties, even antioxidant benefits, and possibly helping to minimize bone loss. So it could be like a multifaceted internal defense system that just functions better when those internal creatine stores are higher.
So it's really about the optimal fueling and the intrinsic health of the muscle tissue itself, not just its sheer size. It almost reminds me of how a well-maintained car engine runs more efficiently and lasts longer. It's not just having a full gas tank, but having optimal lubrication, clean filters, good internal component health. Our muscles might be operating on a similar principle with creatine.
That's a fantastic analogy, actually. The study really highlights that muscle mass and the total creatine pool size are related but distinct metrics. It's their ratio. the intramuscular creatine concentration, that showed this independent importance for predicting outcomes.
Ah,
Even after they specifically adjusted for muscle mass index in their models, the association between higher IMC and lower mortality remains strong, particularly in women.
so muscle mass is good, but high AMC adds something extra on top of that.
It's exactly. Muscle mass itself is protected for many reasons. A protein and energy reserve, it aids in fall prevention, improves insulin sensitivity, reduces inflammation. But IMC appears to add another critical layer to that protection, reflecting that internal cellular health. And that brings us back to the really remarkable sex differences they observed, with the association between intramuscular creatine and mortality staying so robust in females, but essentially disappearing in males after the full adjustment. That really stands out as a central enigma from this study.
It really does. It almost makes you think of the body as having slightly different operating systems for men and women, even down at a fundamental cellular level, doesn't it? What are the potential explanations for this significant disparity? It's not every day you see such a clear divergence in health outcomes for a fundamental compound like creatine based on sex.
You're right, it's a profound observation, and one that definitely needs more research. The researchers themselves hypothesized that potential explanations could involve several intersecting factors. There might be hormonal regulation differences at play, with sex hormones like estrogen and testosterone influencing creatine metabolism or transporter function differently between men and women.
Okay, hormones make sense as a potential driver.
Or there could be inherent sex-specific differences in the creatine transporter's expression or activity itself, meaning perhaps women's cells are regulated differently in terms of getting creatine inside, even if the gene is on the X chromosome. And finally, there could be differential dietary patterns or overall metabolic factors influencing creatine homeostasis between the sexes that weren't fully captured. This is definitely an area that's ripe for future research to really pin down the causality and the specific mechanisms. Because honestly, the existing literature on sex differences in creatine metabolism isn't entirely consistent, which makes this strong finding even more intriguing and important to follow up on.
Absolutely. Now, this was clearly a massive undertaking, covering thousands of people over a decade, and navigating some complex biological measures non-invasively. What were the key strengths that make these findings so robust and trustworthy in your view?
Yeah, the strengths are indeed significant. First off, you have a large, well-characterized population-based cohort, the PREVEND study. That means lots of people followed for a long time. That long-term follow-up is crucial. This provides substantial statistical power, not just for the overall group, but importantly for those sex-stratified analyses.
Allowing them to see those differences clearly.
Exactly. And it allowed for extensive adjustment of many, many potential confounding factors, things that could otherwise muddy the waters. And as we discussed, that non-invasive method they developed to estimate intramuscular creatine using urinary creatinine and BIA was a huge advantage for a large study like this. It made it feasible and scalable in a way biopsies never could be. Furthermore, they did conduct extensive sensitivity analyses. They essentially reran the numbers using different assumptions or methods like different BIA equations and consistently confirmed the robustness of the observed association, especially that strong link in females.
Yeah.
That adds a lot of confidence.
Right, that sounds very thorough. But of course, no study is absolutely perfect.
Yeah.
What should we keep in mind as potential limitations when we're interpreting these really interesting findings?
You're absolutely right. It's always important to consider limitations. The main one, as with all observational studies, is that it cannot establish causality. We see a strong association, particularly in women, between higher IMC and living longer, but we can't definitively say from this study alone that the higher IMC caused the lower mortality.
Correlation doesn't equal causation, the classic reminder.
Precisely. There's always a possibility of residual confounding, meaning there might be other unmeasured lifestyle factors, maybe genetic factors, or dietary nuances that could influence both IMC levels and mortality risk, and the adjustments might not have fully captured everything. Also, while the BIA method for estimating muscle mass is good and validated for large cohorts, it's still an estimate. It could be influenced by things like hydration status or maybe unusual body fat distribution.
But the sensitivity analyses helped with that.
They did. As I mentioned, using different BIA equations and finding similar results largely mitigates that concern, but it's still an estimation technique. And finally, the study didn't have data on creatine supplementation habits among the participants. While likely not a huge factor in this general population cohort compared to, say, athletes, it could be a factor for some individuals and would be an interesting variable to include in future research looking at this connection.
Okay, that all makes sense. So, wrapping this up, what's the big takeaway message from our deep dive today? What's the core insight we should hold on to? This cutting edge research seems to fundamentally shift our understanding of creatine and health. It convincingly reveals that it's not just about having creatine in your body, and perhaps surprisingly, not even about its levels floating in your blood. What truly seems to matter, especially shining through for women's longevity, is the concentration of creatine packed away within your muscle fibers, your intramuscular creatine. This appears to be a strong and independent predictor of lower all-cause mortality, offering a powerful new lens on muscle health and potentially healthy aging.
Absolutely, and I think this study serves as a powerful reminder of how much we're still learning about our own bodies at a fundamental cellular level. We think we know a compound like creatine, but there are layers to uncover. Given these really remarkable sex differences, that stark divergence and the very strong protective association observed primarily in females, we're left with a truly compelling thought to ponder, aren't we? If optimizing our internal intramuscular creatine stores could genuinely contribute to years of vitality and resilience, particularly for women, what simple, personalized shifts could you, the listener, consider making? Maybe through diet, maybe through specific types of exercise known to impact muscle metabolism, or perhaps even considering targeted supplementation under guidance. What could you do to potentially fuel your future health and enhance your own muscle quality from the inside out? It certainly encourages all of us to think beyond the obvious supplement headlines when it comes to vital compounds like creatine and their potentially profound impact on how well we live, and maybe even for how long.